Hi everyone. So I do want to do a quick video on all of the trig functions. I hope everyone is doing okay in class. I hope you guys have everything that you need. I have been working with the sub and I really miss you guys. You have no idea how much I miss work. But I did want to do a really quick video. I'm going to try to keep it short. And we're going to focus on the trig function. So this is what you have been learning with sine, cosine, and tangent. Now, what helps me and my little trick to this, and I love this stuff. So what made this so much easier for me when I learned it was instead of thinking of this as like sine, cosine, tangent, I did a little, there's a word for it, and I didn't make it up. Someone gave it to me. But it is called cotangent. And I know this is a weird word, like it's not something we would use in our everyday, but, and then I usually, just because I'm me, I separate it with like little dots or something, just so I know the difference. This one is color coded, but if you don't have the colors, you can do little dashes or something. So SOHCAHTOA doesn't mean anything, but each letter means something. So the three functions that we've been talking about have been sine, cosine, let me do this color. So cosine, so it's like sine but with a co. And then tangent. So tangent is out like this, tangent. We don't actually write all of these words out. We just put sine, that's not much of a difference. We just drop the E. And then cosine, we do cos. And then tangent, we just do the tan. Okay. Now for each one of these, the most common symbol that you'll see is this one here. And that's just, it's like a variable, but like in a different language. It tells you your reference point. But for now, I'm just going to put it on there right this second. It doesn't mean anything. I'll show you what it means once I do the triangles in this bottom section, but it's just giving us the reference point, like what corner of our triangle are we talking about. So you'll always have a symbol, and it's not really a variable because then it confuses us. So let's start with S-O-H. SOHCAHTOA. You notice there's an A, and then, so the three letters you're looking at are O, H, and A. For sine, you're going to be, whenever you talk about a sign of something, you're going to take the O stands for opposite. So you look at your reference angle, and then you take the one directly opposite of it over the hypotenuse. And you should know what a hypotenuse is. A hypotenuse? I'm pretty sure I misspelled that. I usually just put H-Y-P. That's totally misspelled. I'm sorry if someone who knows how to spell it is looking at me. All right, so sine is always opposite over hypotenuse. That's like the formula. That's the equation, okay? Cosine is ca, so the new letter in here is the A. The A stands for, and I'm going to misspell this one too because I usually just put ADG, adjacent. Hold on, let me look it up. All right, Siri, help me out on this one. So adjacent, and adjacent is just a really fancy word for meaning next to. So you have something that is the opposite side and then something that is next to it. And then you're still talking about the hypotenuse. And this is the correct spelling. I added an O in there, but this is the correct spelling here, according to Siri. And then tangent, we're going to keep the same definition for the O and the same definition for the A. So we saw the O in sine, which told us opposite. So that's going to be tangent is the opposite. And I'm going to abbreviate it. I will usually just keep the shorter one. And then the A in cosine meant adjacent. So we're going to keep that. And that's our three equations or formulas. This is really all you need to know. So I'm going to pause it here, draw a little triangle so you don't have to watch that. All right, so we're going to look at this triangle here. Now, when we use SOHCAHTOA for this section, we're dealing with right triangles. And you know what a right triangle is because it has that little square looking thing in this section. So whenever you see this, you know that that's going to be your right triangle. Oh, you know you have a right triangle where that's your 90 degrees. Now, every right triangle has a hypotenuse. So I'll do this in really light yellow so I can write over it eventually, maybe. So this is going to be our hypotenuse. That means it's the longest side. What I used to tell my freshmen when I did this is consider this like an arrow, right? The little box of your right triangle will always point to your hypotenuse. So if that helps you, it's always the longest side. But that's your hypotenuse. And then we're looking at theta. So this little funky sign right here is theta. It's a Greek letter. It's just a symbol. You don't have to do much with it. It's just a different, like instead of writing X, you're going to write theta. And we usually use the Greek symbols when we're talking about angles. So inside of a triangle, it kind of helps us separate what we're looking for. So if you see a Greek symbol, you know you're looking for a degree for inside of the triangle. And we'll get to that. But right now, that's a hypotenuse. So the theta that we are given is up here. You could be given the theta down here also, but it really depends. So right here, it's here. It could have been here, but it wasn't. It would be the same thing. Your equations would just be differently, but I placed it here. Now I'm going to give these just random values. They might not even work out nicely if you try to do the Pythagorean theorem, but I'm just picking random numbers. So let's say 3, 4, and 5. I want to know all trig functions. There's actually 6 of them, but we've only done 3 so far. So I want to know the sine of theta, what that equals. I want to know the cosine of theta, what that equals. And I want to know the tangent of theta and what that equals. So I know that each one of these will be fractions. So fraction, fraction, fraction. All right, so for sine, it's so, which tells us sine is opposite over hypotenuse, opposite over hypotenuse. So I'm going to take my theta. Because this is sine of theta, you need to look at this. This is where you're going to be considering your opposite and your adjacent from. You're not even looking at this angle right here. You just want to look at the theta. So since this is the opposite, we're going to look at the one that is directly across the triangle. So here is our theta. Across from it is 4. So this is 4. Hypotenuse is the 5. So 4 over 5. Again, you look at your theta as your reference point. What is the opposite side of that? 4. Let's look at cosine. So cosine is adjacent, remember that means next to, over hypotenuse. So I know the 5, and I'm going to take adjacent. So here's my theta. What is next to it is the 3. Yes, it's true that my hypotenuse is also next to it, but that's my hypotenuse. So I need to look at the side, not the hypotenuse. So you look at your 3 over the hypotenuse, which is the 5. And then my tangent is opposite over adjacent. So here, theta, opposite we said was 4. Adjacent was 3. And that's all we're really doing when we're listing them. We are just taking opposite, next to, and hypotenuses, and then putting them in our fractions here. If you could simplify these, you would. If you can't, you can't. And then we'll end up using these eventually to solve for theta, but we're not there yet. That's a few sections down the line. Okay, we will also be talking about the inverses of these. So we would have cosecant, which is represented by this. So cosecant, we will be finding the inverse of cosine is called secant. And then the inverse of tangent is cotangent. So we'll come back to this one problem when we talk about these. Right now, I just wanted to introduce it. We're going to end up doing these Sorry, it's really easy once we find these. But they do have opposites that sound like that. Okay, so let's start doing some actual problems with these things. There's going to be times when you're going to be given a triangle with I gave you all three sides. You might be given a triangle that doesn't have all three sides. So say, for example, could have done this bigger, I guess. So this is your reference angle, theta, and this is going to be 5, and this is going to be 7. So in order to find the SOHCAHTOA, we need to find this side here because that's our adjacent. We can't just leave it blank. We need to know first what that is. That's going to take us back to geometry, to Mr. Pythagoras. So the Pythagorean theorem, and I really hope I spelled that right. I'm not a good speller. Which says that a squared plus b squared is equal to c squared, where c is always your hypotenuse. So all we do is, and it doesn't matter which one you label a as and b. So I'm just going to say a is equal to 5, and then this one here is b. I know that you can't really see this yellow, but that's kind of my intent because I'm going to be writing things that are more important there. So I'm going to plug in my a and my b and my c to try to solve for this missing side right here. So let's do a is equal to 5. So this is going to be 5 squared plus b is what we're actually looking for. And then c, since that's my hypotenuse, remember it's directly across from the right angle, is 7 squared. So 5 squared is 25 plus b squared is equal to 7 squared is 49. So b squared is 49 minus 25. Minus 25. That gives me 24. Take the square root of both sides. So b is equal to the square root of 24, which if we take it off to the side, I should have picked an easier example. We get 2 rad 6. Okay. The good thing is I actually think that this is one of the ones in your homework assignment. So it was a little bit difficult, but I just did it. All right, so this missing side here is going to be b is equal to 2 rad 6. If you look back at when we simplified radicals, I just broke this up into 2 things. The square root of 4 was 2, and then I just brought down my radical 6. Okay. Yeah, we did all that work, but we haven't really solved the question here. They want to know what are the functions to this. So I want to know sine, cosine, tangent. Now that I have all 3 sides, I want to know sine of theta, cosine of theta, and tangent of theta. Yes, 2 radical 6 is something ugly to look at, but we're not actually doing anything with it right now. We're just copying it over. So it's okay that it's ugly. Sine, so here's our theta. Sine, according to SOHCAHTOA, is opposite over hypotenuse. So I'm going to take the opposite, 5, I should change the color. Over, so opposite over hypotenuse. Ka is adjacent over hypotenuse, so 2 radical 6 over hypotenuse. And then the tangent is opposite over adjacent, so opposite was 5 over adjacent 2 radical 6. Now, they're going to probably not accept this answer because you have to rationalize the denominator. And this is something else that we did I think we did this in semester 1, where it tells you that you can't have the radical in the denominator, so you need to multiply top and bottom by that radical 6. So remember, outsides with outsides only. So 2 times 5, or 5 times 2, sorry, is 10 radical 6 over 2 times 2, which is 4, 6. I'm just going to write it right here. So 10 radical 6 over 24, which you can keep simplifying to say 5 radical 6 over 12. This is called rationalizing the denominator. We've done that. That just says that you can't have the radical in the denominator, so you need to multiply both top and bottom by it, which cancels out the radical. It gives you just the 6. And then from there, I just simplified. Okay, the next thing I want to do is something like this. When you're given one of the measurements and you have to find the rest of them based off that one. So I'm going to do, let's just do 13. Which tells us that we have sine of theta is equal to 7 over 11. So this actually gives us 2 measurements of a triangle. Now you may want to draw your triangle like this, you may want to draw it like this, you may want to draw it, I don't know, differently. But as long as all of your angles stay consistent, it doesn't matter which direction your triangle is facing. So I'm just going to pick it down here. If you drew your triangle and you made your theta up here, it just means your numbers will be swapped. Obviously, my triangle is not drawn to scale. So as long as it's consistent, the opposite is at the opposite position, the adjacent is at the adjacent position, the hypotenuse is where the hypotenuse should be. It could look however you choose to make it look like. Now, with sine, we know that this is opposite over hypotenuse, because this is the SO of our SOHCAHTOA. So sine opposite over hypotenuse. So that means that the opposite of this is going to be 7. The hypotenuse is going to be 11. So again, we're missing one of the sides, so we have to do the Pythagorean theorem again. So we can name these A and B again, as long as this is always your C, because it's your hypotenuse. When you plug these in, oh, I should have said 11 squared. Give me 1 second. I'm moving too fast here. I moved too fast, so that would be C, which is 11, so 11 squared, which multiplies out to 121, and 7 squared is 49. And then we're just going to go ahead and solve for B here. So I did that off camera just to save time. Subtract the 49 on both sides, I got 72. Then I took the square root of both sides, I got the square root of 72, so I split that up into 36 times 2 gives me that 72. The square root of 36 was 6. So my B here is actually 6 radical 2. Now that I have all 3 sides, I can go ahead and find my SOHCAHTOA. Sine was given, cosine and tangent. So we knew our sine based off of our problem. And we use that to find the other. So cosine is adjacent. That's the ca part, so SOHCAHTOA. So the ca is adjacent over hypotenuse, which is 6 radical 2 over 11. And then the tangent is the opposite over the adjacent, the TOA opposite adjacent, which is, sorry, opposite adjacent. So 7, 6 radical 2. Again, we can't have the radical in the denominator. 42 over 3672. So then you could simplify that. Let me move it up. You can simplify this. 2 Let me zoom out so you can see the whole thing at once. So again, I use the measurements that were given to me to find my triangle, use the Pythagorean theorem to find the missing side. Now that I had all three, I can find my SOHCAHTOA because it's opposite over adjacent, adjacent over hypotenuse, and then opposite over adjacent. Keeping in mind that you have to rationalize the denominator. So that's it for this first part for SOHCAHTOA. I'm going to continue on this video to teach you the others, the secant, cosecant, and tangent. They're actually really, really easy. But before I forget, I want to show you on your calculator where you could find this. So most of you have iPhones. I have an iPhone, so that's kind of going to be what we're going to use. That's my grandma. So there's my calculator. If you have an Android, maybe you can YouTube something. I don't. So I don't know. But if we had to use measurements, you're going to take your calculator and you're going to flip it sideways. Mine doesn't want to flip sideways. Oh, I think it had to be unlocked, right? You flip it sideways and it looks like this. So you notice that you have sine, cosine, and tangent there. If it were to ask you for a decimal to a certain extent, I'm just going to do this one because it's here. So you would do 5/7 first, and then you would take the sine of it, and you would get that. All right? Okay, so that kind of does the sine, cosine, tangent portion of it. I'm going to jump right into the cosecant, secant, and cotangent now. Okay, so I went ahead and I copied down everything that we already know. This is what we learned in that last page of the notes, the first 20 minutes of this video. We know that sine is the opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is the opposite over the adjacent. If I go back to my calculator, you notice that I have the signs for sine, cosine, and tangent, but I don't see any of the other ones, which were the cosecant, the secant, and the cotangent. That's because you don't really need a calculator to solve it. These are the three new ones that we're going to do, the cosecant, the secant, and the cotangent. So the cosecant is the inverse of the sine. They kind of go together. The secant goes with cosine, and then the cotangent goes with tangent. This one's really easy to remember because it's just co and then what it is, which is tangent. The secant is the cosine, and then the cosecant is the sine. So I always confuse these two a little bit. I came up with a little pattern in my head because patterns work for me. So to abbreviate cosecant, it's this. So just like sine, we abbreviated it to sine. And in my head, what I did was there was a pattern here, CSC. So the next one should have been the S, which is why it's sine. If you don't get confused with which one's cosecant and which one's cotangent, cosecant and secant, then you don't need the pattern. I had to do it when I was in high school. And then secant is just this one. So you notice there's no pattern here like there was here. And then cotangent is just cotangent. All right. I should have changed colors. I'm sorry I didn't. Okay, so to find your little fraction, all you're going to do is you're going to take your opposite over hypotenuse and you flip it. So it now is hypotenuse over opposite. So again, you take this, you flip it, and you get your new fraction. I have to change the colors because it bugs me. So for secant, same thing. You're going to take the cosine, you take your adjacent hypotenuse, you flip it, and you have hypotenuse, and you have adjacent. And lastly, for cotangent, you take your opposite adjacent, you flip it. So adjacent and opposite. So the words are a little bit more complicated, but the work isn't, once you have these, you just flip them and you find those. So let's go ahead and do that for this, the ones we did at the beginning. So we want to find cosecant. So that goes with our sine. So all I'm going to do is take that 4 over 5. I do the reciprocal, 5 over 4. For secant, I take 3 over 5, do the reciprocal. Oh, sorry. 5 over 3, and then 3 over 4. My recommendation, when you do inverses for things like tangent, you don't want to do the inverse of the final answer because it has the radical. So I would have just taken it from this part, because when you do the reciprocal, it would be a numerator, and then you don't have to do all of this over. If you try to take the cotangent from this answer here, you would end up with, again, a radical in the denominator. So once you rationalize that, you'd end up with the original one anyway, and that's just a lot of work. So when you have to find your cotangent, your secant, or your cosecant, take it from the first one, especially if there's a radical in it, because then you can avoid a lot of work that way. So I could go through for all of these and find the remaining ones, but I don't think we have to. You're just taking it and you're flipping it. You're doing the reciprocal. So I'm going to leave this here, and then I'm going to call it a day. I did forget to pause a few times during the video, so I'm sorry about that. I like to pause when I write things down. But I also changed the big ideas assignment. I changed it from being due, what was that, 5-3? I changed it to be due the Saturday. So it's a week from this Saturday, 5-8, at 11:59 p.m. because you won't cover these until next week with sub. So I just wanted to make a note of that. I know there's like 2 people that submitted already, which is very impressive. But yeah. So make a note of that small change. You still have to submit your work. Okay. That is all I got for you guys. Be good, be great, to be beautiful. I hope to see you guys soon. And if you're going to prom, have fun. Be safe. All right, that's it.